In this problem, a uniform wire of resistance 9 ohm is bent in the form of equilateral triangle. Find the resistance between any two resistors of a triangle. Like that they are given. A uniform wire is there. Let us take this a uniform wire of resistance 9 ohm and it is of a length L. I will take length L. It is bent in the form of equilateral triangle of an equal sides, like that the length is going to be L by 3, L by 3 and L by 3, like that this length of these particular sides of a triangles, they are equal because equilateral triangle they are given, and based on this what happened, resistance of this each side of this triangle, earlier this entire wire as a length resistance is a 9 ohm. You know that the resistance is directly proportional to length. As the length is reduced to L by 3, then resistance also it is an R by 3. That implies resistance also reduced to R by 3. Like that, this resistance of each part, because it is equilateral triangle, the resistance is reduced to R by 3 as 3 ohm, 3 ohm, 3 ohm. Now, look at these pictures, and there will be a triangle is there, and each side of this triangle has a 3 ohm resistance. The triangle made up of uniform wire. What is they asked in the problem? Find out the resistance between any two resistors. ಈ ಎರಡು ರೆಸಿಸ್ಟರ್ಸ್ ನ ಮಧ್ಯದಲ್ಲಿ ಎಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ಇದೆ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಲಿಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ. Okay, and then we have to find out. Look at this from figure. Suppose you connect a battery. If you connect a battery or you apply a potential difference, you are applying like this. Then these two resistors are in series. And these two resistors series combination is parallel to the third one. Like that, from figure I can say this is R1, this is the R2, and this is the R3. R1 and R2 are in series. Then what is that? Series resistance. We know that effective resistance is going to be R1 plus R2. Like that is a 3 plus 3 is a 6 ohm. Effective resistance of these combinations, and you can find out like this. The upper part is 6 ohm, the two resistance, and lower part we have a 3 ohm. Then look at these pictures. Now these two resistance are series. I get a 6 ohm, and these two resistance is parallel to this 3 ohm. Because of that reason, the resistance between these two resistors becomes, it is a combinations is like a parallel combinations, and like that we have to use this formula. Is the R1 into R2 divided by R1 plus R2. If the two resistance are in parallel, like that this is the two resistance in parallel now. The 6 ohm and 3 ohm is 6 plus 3. Like 6 into 3 is then 18 divided by 9. The effective resistance will be 2 ohm. This is the answer. Okay. That effective resistance between two resistors is 9. 18 divided by 9 as a 2 ohm. This is a way of solving this problem. See, this is a problem based on this resistance in parallel. Okay. See, the problem is given two resistance of 3 ohm and 6 ohm are connected in parallel with a battery of EMF 6 volt and internal resistance 1 ohm. Calculate the main current through the resistance and current through 3 ohm and 6 ohm. Okay. First we have to draw the diagram for this particular problems. There will be two resistance 6 ohm, 3 ohm and 6 ohm are connected in parallel. Okay. Let us take this R1 is 3 ohm and R2 is 6 ohm are connected in parallel as given in problem. and these resistance are connected for a battery of EMF 6 volt, battery of EMF 6 volt, and internal resistance of the battery is 1 ohm. Internal resistance is 1 ohm. This is a given, and you can write like this: given data, EMF is 6 volt and internal resistance is 1 ohm, and two resistors R1 and R2 is 3 ohm and 6 ohm. Now what is they asked to calculate? They asked to calculate main current I and also current to this resistance. Let's take this I1 and current to this resistance. So this is the directions, positive to negative. Current through this resistance R2 is I2, and also the main current I. These are the things they asked to calculate in these problems. Let us solve this problem. How to solve? See, we know that two resistors are in parallel, but the effective resistance, that is going to be sum. The reciprocal of effective resistance is sum of the reciprocal of individual resistance, and based on this we have a formula: 1 by R S is equal to 1 by R1 plus 1 by R2, that I can rewrite as RS or R effective is R1 into R2 divided by R1 plus R2. Let us substitute these values of R1 and R2, that is a 3 into 6 divided by 3 plus 6. The 3 into 6 is a 18 divided by 9, as a result is a 2 ohm. Now effective resistance of this combination is 2 ohm. Then we have to find out what is the main current. The main current I, in a simple circuit we studied what is the expression for current. I is equal to is the E divided by effective resistance or effective plus internal resistance of the cell, that is a small r. Okay. I will substitute these values here. E is 6 volt and this effective resistance is 2 ohm and internal resistance is 1 ohm. That total is a 6 by 3, that is 2 ampere. 2 ampere. This is the one answer. 2 ampere, that is a main current we got, 2 ampere. Now we have to find out what is the current to these branches. This current through R1, current through R1, that is I1, that is equal to main current into resistance in opposite branch, that is R2 divided by sum of these resistances, that is a R1 plus R2. This is a formula. The main current into resistance in opposite branch plus sum of the resistances, and like that the main current is, we got 2 into resistance in opposite branch is 6 divided by this 3 plus 6, 3 plus 6, like that it is a 12 divided by 9. Okay, 12 divided by 9. Suppose if we simplify, we will get these answers for this I1 is 12 by 9. We simplify in calculator. We will get 1.333 something. I can write 1.334 ampere. This is a current through this resistance R1. Similarly, current through this resistance R2. Current through R2, that is I2. I2 will get like this: I1 into R, I into R1 plus R1 plus R2, as it is. The main current into resistance in opposite branch divided by sum of the resistance. Like that, if we simplify, we are getting main current is 2 into 3 divided by 2 plus 3. Sorry, 3 plus 6. So that is a 6 divided by 9. that is 0.666, we are getting 67 ampere, and this is the answers. Okay, we got main current is 2 ampere, currents in a resistance R1 is a 1.334 ampere, and current to this resistance R2 is 0.667 ampere. This is another problem is asking for 5 marks, a simple problem. The three resistors 1 ohm, 2 ohm and 3 ohm are connected in series. What is the total resistance of these combinations? Having three resistors 1 ohm, 2 ohm and 3 ohms are connected in series. What is the total resistance of these combinations? That is the one part. Then if this combination is connected to a battery of EMF 12 volt and negligible internal resistance, this internal resistance is negligible, very small, okay, then you have to take a 0. Obtain the potential drop across each resistors. Obtain potential drop means what is the potential difference between each resistors, that I have to find out. Okay, like that I will connect a battery of internal resistance is 0, I have to take internal resistance is 0 and EMF is 12 volt. Okay, EMF is 12 volt. Then what is the potential drop across the first resistance V1, potential drop across second resistance I will take V2, and potential drop across third resistance V3. V1, V2, V3 I have to find out. First part, what is it? It's the total resistance. Total resistance of this combination. Since the resistance are in parallel, then total resistance is Rs, that is getting as R1 plus R2 plus R3. This is the sum of this resistance 1 plus 2 plus 3, that is a 6 ohm. This is the one part, total resistance of these combinations. Second, what is the potential drop? Potential drop or potential difference across resistance R1 or 1 ohm, I will write resistance 1 ohm, and that is I will write like this: the potential drop V1 is equal to current into its resistance. I have to find out what is the current and resistance. How to find out current? Current is equal to the EMF divided by its effective resistance, that is a giving current, into its resistance R1. So that you will get substituting here 12, EMF is 12, its effective resistance is 6 into this R1. This is a resistance 1 ohm, so that you will get a 2 volt. This is the potential drop across this. 12 divided by 6 is 2 volt. 2 into 1 you will get a 2 volt. Okay, that is the potential drop across the resistance R1. So that was the potential drop across the resistance R2. Potential drop across the resistance R2 or 2 ohm. Potential drop across 2, that I write V2. Now this current I into R2. Current I already calculated, is a 12 by 6 or 2. I can write like this: 2 into 2, 4 volt. So that will get 12 by 6 is 2, 2 into 2 ohm. Similarly, potential drop across 3 ohm. Potential drop across 3 ohm, that is a V3. That I will write again I into R3. This is a formula. This is applied for a when resistance are series. Potential difference we can find out like this using Ohm's law relation. V is equal to I into R. I is the main current. Since current is same in all through resistance, I have taken as 2 only. 2 into 3. That is a 6 volt. And we can verify it also. The total potential drop across this combination should be is equal to sum of the potential drop. There is a V1 plus V2 plus V3. What is here getting? V1 plus V2 plus V3 is a 12. Total potential difference also 12. So that your problem you can verify using this. Look at this problem. There will be two resistors 8 ohm, 12 ohm are connected in series across a potential difference of 10 volt as in figure. Will be two resistors are connected series across a potential difference of 10 volt. 10 volt. Calculate current to the circuit. This is one part. Calculate current to the circuit. Then you have to find out what is the effective resistance. Then we have a potential difference. Then you can find out a current. That is one part. And also calculate current. Sorry, when another resistance, if you connect another resistance of unknown resistance in connected in parallel with the two resistors, ಈ ಎರಡು resistors ಗೆ parallel ಆಗಿ ಇನ್ನೊಂದು resistance ಅನ್ನು connect ಮಾಡ್ತಾರೆ. Whose resistance is unknown, let us take as a resistance is X. The unknown resistance is connected to this parallel, in parallel with them two resistance in series. Then current changes, whatever current here is there, no? This changes to 2.5 ampere. Whatever current here we have found in first part, and that is changes to 2.5 ampere. And when a resistance in parallel, current is changing. Like that earlier two resistance series, now I connect another unknown resistance parallel to this resistance, then definitely current is changing. That what is the current changes is given. Calculate this unknown resistance, calculate the value of x value and find out ಮಾಡಿ. And first we have to find out first what is the total resistance in this series. It is then 8 plus 12, that is a 20 ohm. The total resistance is combination is 20 ohm. Then what is the current to this series resistance, that is I is equal to this potential difference V into the resistance, V is equal to into V by R, that what is the resistance RS, that 10 divided by this resistance in series is 20, that it will get a 0.5 ampere. 0.5 ampere. This is a current we have to find out in a first part. Two resistors are connected in series across a potential difference of 10 volt. Calculate current. We got the current is 0.5 ampere. Now the another resistance of unknown resistance connected in parallel, then what happens is effective resistance. Then what is the given current is changes to I, what is the I is given is 2.5 ampere. When X is connected parallel to RS, then it is the effective resistance. What happens is effective resistance we can find out like this is a sum of this, product of this resistance divided by sum of this resistance. I can write R1 into R2 divided by R1 plus R2. Here I can write is the RS, total resistance in parallel, series, RS into X divided by RS into X. RS we already find out, like that what is the effective resistance of this combination is going to be 20 into X. I'll write 20X divided by 20 plus X. But X value I have to find out. But there will be given another data. What is the current? Current they are given. Current is equal to 2.5 ampere. Current changes. I dash, right? I dash is given 2.5 ampere. Then current into resistance is equal to potential drop. Potential drop is same 10 volt. I'll get 10 volt, and this 2.5 I can write as 2.5 into 20x divided by 20 plus x is equal to 10, or 2.5 bring this side, we can simplify and we can find out x value. Only x value is unknown. This is a into, don't confuse, this is a 25 into 20x divided by 20 plus x. I can take this to this side, 20x, this I'll bring here, 10 divided by 2.5, and this I can take to this side, say 20 plus x. See, you can carefully have to simplify. This is 4 times, whether this 2.5, 10 divided by 2.54, then this also you can simplify like this, and this is a 5 times, you can write 5x is equal to 20 plus x. 20 plus x. X I will bring to this side, then it's a 5x minus x is equal to 20, or 4x is equal to 20, 4x is equal to 20, x is equal to 20 by 4 means 5, 20 by 4 means 5, so that 4x is equal to 20, 5x minus x is 4x, 4x is equal to 20, x is equal to 20 divided by 4, that is 5. This is the value of unknown resistance we can get from this problem. Okay, this is another